on here, and it should show that it is recording. I'm just going to trust that it is. Yes, it is. Okay, welcome everyone to the Modges College Workshop. This is one of many series. As you know, our motto is can't stop, won't stop. Whether pandemic or not, we are a community to support each other, and today's kickoff shows a great representation of that today. We have some special guests today, some wonderful, amazing students from UC Berkeley, who I'll introduce in a moment, where they're going to talk to you guys about not only UC Berkeley, their experiences, but the hottest major that's out there is civil engineering. And I have to just give a little shout out. I don't know if the presenters know, my sister, who was not only first gen, but the first person in multiple families with us, went to UC Berkeley as a civil engineer, and it has brought so much wonderful opportunities. It has been beautiful, where it's also inspired her son to be a second generation civil engineer. And so remember, there is no limits to all the possibilities. But enough for me. You're not here for me, you're here. So let's introduce and let's get a great wave. So we have Kayla with us. She is an ASCE alum from class of 2017. All right, she's a fourth year CEE, so civil environmental engineering student. And she's also a vice president of Cal ASCE, which she's going to talk to you a little bit more. So welcome, Kayla. Give a big old modest wave out there, even if virtually or spiritually. And then we also, and then let me tell you a little bit more about Kayla. Kayla's from Daly City, second gen Philippine X, American, first gen college student. She uses the pronouns she, her, and hers. And also she's interested in Bay Area food, who wouldn't, and sports, R&B music, boba, oh my God, boba, of course. Okay, now we have in the house, we have Parson. His pronouns is he, him, and his. He's also a fourth year CEE, meaning again, civil environmental engineering student. He is the president of Cal ASCE. He's from Los Angeles, California. Got to give some love out there for LA. He's also first gen Filipino X-American and first gen American college student. His interests are photography, gotta love it, fashion, stencil art, and he is open to Netflix recommendations. Go put that in that chat room, right? Mine's Amazon Prime called The Boys, FYI. Okay, and then this is not the last person that we're gonna give great praise for today, but we gotta give a shout out to Justin. He is our second year CEE. His pronouns are he, him, and his. He is also at Cal ASCE, and he is a junior vice president. He comes from not too far from us, San Jose, but now he's living in Fremont. A fun fact about him, he used to be a competitive swimmer and have taught swimming for around 5 years. His interests are outdoor activities, sports. So he also wants to know some new places to go to. So recommendations. Continue showing that modest love. And so everyone, let's give some either emoji reactions out there or a big round of applause to all our wonderful guests. Kayla and all Parson, and also for Justin, please feel free to let our students know why you're here, about UC Berkeley, your experience, all the good and the bad, because that's what makes life so interesting. And of course, the amazing major of civil environmental engineering. It's all yours.
Thank you, Ms. Vaccaro, for that wonderful introduction. Am I actually able to share my screen right now? If possible, can you please give me the host settings? Okay, looks good. Okay, thank you. Really quick. Okay, yeah, so good afternoon, everyone. It's truly an honor to give this presentation to you all today. Thank you again to Ms. Vaccaro and everyone at Modges for providing us this opportunity to do this. And of course, thank you to you all for being here and showing up. So a little introduction of ourselves. I know Ms. Vaccaro touched upon us. Again, my name is Kayla Kuraming. I go by she, her, hers. I'm a fourth year at UC Berkeley, and I graduated from SI 3 years ago in 2017. And of course, I'm studying civil and environmental engineering. And I'm here presenting with two of my peers from our campus student organization, the American Society of Civil Engineers at Berkeley. Parson and Justin, do you want to give another intro really quick?
Just to recap again, my name is Parson. I'm a fourth year civil and environmental engineering. I'm originally from Los Angeles, and I'm just really excited to be here with you. Thank you for sharing your time with us, and I really hope we can teach you something today about civil engineering, because it is a hot major, as Ms. Vaccaro mentioned.
Yeah, hello guys. I'm Justin. I want to thank you guys for coming here today and listening to us. And as Parson and Kayla said, civil engineering is really a great major to be in, so just keep an eye out for it.
Cool. So I know we're speaking with, it looks like a variety of classes, so like seniors, juniors, sophomores. It's great that you're all here. So around this time is when college applications, people are working on college applications, and over the next couple of months, you'll be pretty busy working on that and doing essays and scholarships. But we all know that you'll get through it with the support of one another. We were all once in your shoes, and we're here to help guide you and help you along the way. So yes, with this presentation called Intro to Civil Engineering, we wanted to inform you of the possibility of civil engineering as a potential major and career path for you. But above all, we wanted to inform you because we weren't, as high school students, we weren't really exposed to what civil engineering was. No one really came and like told us this is what civil engineering is. So whether you're interested in math, science, business, etc., civil engineering is a pretty broad major. It's everywhere, and we need civil engineers in this world. So here is our agenda for today and what we intend to cover during this presentation. We'll be giving a brief description of civil engineering. And we wanted to ask you all if you have any prior knowledge or ideas of what this field or industry is. Then we'll speak a little bit more about who we are as an organization, as ASCE. And then we'll go into 6 different civil engineering disciplines. There's actually more than the 6 that are listed here, but we find these 6 to be the most foundational. And we'll spend about 5 minutes each explaining what they are and why they are important. Then we'll discuss more of our personal journeys and stories, what it's like to be a civil engineering student in college, the kinds of courses we've taken and how we get involved with the organizations we're in. And then lastly, we'll have some time for Q&A where you could ask us any questions. So yeah, as Ms. Vaccaro said, during this presentation, we please ask that you participate as much as you can. We want this to be as interactive as possible so that you can get the most out of this. Whether engineering is something you're into or deciding on, we hope you can learn something from this presentation. Without further ado, I'll pass it on to Parson, who will be leading a quick short exercise.
Awesome, thank you, Kayla. I just saw the chat was disabled. I wanted to drop a link in the chat just to get the students ideas as to what currently they think civil engineering is. I think it's just going to be a really interesting experiment to figure out, you know, where we're all at in terms of understanding of civil engineering. So I'm wondering, Ms. Vaccaro, if you're able to enable that at this time. Ms. Vaccaro, I believe you're muted.
Thank you. I think that's an option my husband wished he had on me. So if you could, yes, I have no problem of opening it up. You want to tell me what feature I need to press to give you access to the chat? Do you know? I think it's something I just, it's in settings, but so you're not able to go into it now, correct?
No, but
Or,
on the screen,
if you see the screen, yeah.
Mm-hmm.
on the screen, if the students are able to text CalACE 879 to 2233, you can respond to this question, and then we'll
Oh,
see all
great.
the answers real time.
Thank you. And I'll put in the chat when I'm able to do that. I think it's just disabled for right now, but I'll figure it out. Thank you. Sorry.
Awesome.
Oh, everyone could go on the chat now. Just figured it out. Sorry.
Awesome. I just sent the link on the chat if that was easier for anyone. Awesome. So first one we have is bridges. It's fairly common as to what everyone thinks civil engineering is, and they're not wrong. It's definitely a subset of civil engineering. We'll get into that later on.
If you're really not sure, you could also say, I'm not sure. I also didn't know too much as a high school student.
I also didn't know a lot as a high school student. Okay. Yeah, I guess we can just start with the introduction of what civil engineering is. We totally understand. I did not have this experience as a high school student to understand what civil engineering was. It was more of just a touch and go experience for me trying to decide what I wanted to study in college. But for the next slide, Kayla. So what exactly is civil engineering? Well, everything around you, all infrastructure in the entire world is essentially some sort of way entangled with civil engineering. So that's any physical infrastructure around you, as well as now in present days with technology, some of the technological infrastructure that you have around you is also related to civil engineering. So civil engineers design, build, and maintain the foundation of our modern society. Our roads and bridges, drinking water and energy systems, seaports, airports, and the infrastructure for cleaner environment just are a few options. So an everyday life of civil engineers affects all of us. So whether you were able to turn on your water tap for today or tomorrow, that's because of civil engineers. Whether you're able to turn on and off your lights every night to go to bed, that's because of civil engineers. And there's a lot of things in our everyday lives that are reliant on civil engineering, civil engineers doing their job every single day to keep our infrastructure alive, 24/7, 365 days a year. With that, I wanted to pass it on to Justin to talk a little bit more about exactly what the American Society of Civil Engineers is, what it is as an organization.
Yeah, so about us, can you hear me? Am I unmuted? I'm gonna assume
Yes.
that I am. Yeah.
Yeah.
So about us, the ASCE student chapter at UC Berkeley is one of the many student chapters under the National American Society of Civil Engineers. The overarching ASCE is a professional engineering society with members who represent the civil engineering profession worldwide. Particularly, our organization has a lot to offer to our students, whether it be academic, social, or professional opportunities. Some of the events that we hold include socials, networking events, company info sessions, civil and environmental engineering focused career fairs, and professional development workshops. Through these events, both on the student chapter and national level, students are exposed to many different disciplines within civil and environmental engineering and are provided resources to develop as a student and a future engineer. So if you do end up choosing civil engineering as your major, keep an eye out for ASCE wherever you may end up. I can assure you that it will be extremely helpful through your college experience and in the workforce. I'd like to pass it on to Kayla for our first CEE discipline.
Cool. Now we're moving on to our first civil engineering branch. First off, I wanted to ask you all if there's anything you notice about this photo. Feel free to type it in the chat if you have an answer to this. And I also included a little hint to get you thinking about the things you might observe with this photo. Okay, cool. Yeah, it looks like Matt said, where's the Salesforce building? Yeah, that's actually really true. As you can see, this is probably an old photo of the city before the Salesforce Tower was built and before any of the other skyscrapers were built. So yeah. Now we'll be talking about construction. So in the more general sense, construction is the act of building something and bringing a particular design to life. In this industry, project engineers and managers are in charge of coordinating and running field operations to successfully complete a project within a time frame. And now we will play this time-lapse video of the Salesforce Tower's construction. Unfortunately, it says my internet is unstable, but hopefully this works out fine. Hopefully. Is it playing? Little lag. Okay, I'm just gonna, oh, never mind. So throughout the video, you might have noticed that there is a particular sequence to constructing the tower. After the core of the building is constructed, the facade and the exterior follows all the way up until the tower is completely built, which is pretty cool to see. I just remember when I was younger, when this was getting built, passing by on the freeway and seeing the progress of the building as time went on. So I found that pretty cool to see. And then I'm going to play another video. I wanted to play the beginning part to make another point about the moving parts of the construction project. So hopefully this also plays. Okay, yeah, I just wanted to play the beginning part of the video to illustrate that there's a bunch of moving parts on a construction project. As a project engineer, you'll need to coordinate, as you might have seen with the tower cranes. There are multiple tower cranes on this job site, and you'll have to coordinate when those can be used and by whom, as well as where the heavy equipment, such as the forklifts and the tractors, where the vehicles are supposed to go. So construction involves creating site logistics, planning schedules, and working with other partners on a project, which typically includes an owner and then an architect. I find it cool how the construction industry today is implementing construction technology. So for example, the use of augmented reality on job sites, it's becoming more and more prominent, making the construction tasks more efficient. And it's something that we'll definitely see in the future. So if you see yourself doing construction, you'll definitely touch upon various construction technologies. Now moving on to the next civil engineering discipline. This map is from the American Lung Association in California. As the red regions show, California has some of the worst air pollution in the country. Do you notice anything interesting about where exactly the red regions are located? Feel free to enter anything you observe in the chat regarding why the red regions are where they are. Okay, wildfires. It's definitely a good guess. High temperature location. Yeah, so those are two pretty good answers. So while many communities are at risk due to unhealthy air because of the fires, there's also some guidelines and policies within each region. So some communities face higher risks due to their proximity to freeways, rail yards, freight corridors, and other pollution sources. And unfortunately, lower income communities and communities of color often bear the burdens caused by the local air pollution. But that is a whole different topic. But pollution is definitely one of many environmental issues that environmental engineers try to tackle and solve. So with that, simply put, environmental engineering is concerned with protecting people from the consequences of adverse environmental effects, such as pollution, as well as improving environmental air quality. Environmental engineers use the principles of engineering, soil science, biology, and chemistry, which are things that we start learning in high school, to develop solutions to environmental problems. Engineers in this field address ways in which we can divert waste and develop more sustainable solutions of obtaining energy, amongst other environmental improvements. Now I'd like to draw your attention to the future of environmental engineering and the goals that we as humans should strive to reach. These are called the Sustainable Development Goals, and they were made in 2015 by the UN. There are 17 goals that are a blueprint to achieving a better and more sustainable future for us all, which also addresses the challenges of our world and the people that face these challenges on a daily basis. So environmental engineers definitely play a large role in this. It's interesting to see that many of the environmental goals that are listed here go hand in hand with social and economic goals. Clean water and sanitation, affordable and clean energy, and climate action are definitely some of the goals that environmental engineers address head on, but all of these play a role in developing a more sustainable society. So as an environmental engineer, you'll definitely be touching upon these goals and working with people from other fields and making these goals a reality. And with that, I will be passing it on to Justin for the next discipline.
All right, you guys, for this session, I'm gonna start out with asking you guys why you think this dam you see on the slide right here failed so drastically, as you can see from the before and after. So what do you guys think happened? Feel free to type an answer in the chat or just unmute and tell me your answer. Okay, sheet materials, calculation errors, miscommunication, not built properly, construction, not quite. Oh, erosion, that's a little bit closer. I'll give you guys 5 more seconds to try and guess. Nature, yes. Okay, nature is actually pretty close. So this dam was actually the St. Francis Dam in LA, which was destroyed due to a mistake in the material that the dam was built upon. So the stone that the foundation that the dam was built on is called conglomerate. This type of rock is very fragile and cannot hold too much compression or tensile pressure. Because the foundation of the dam was built on top of this rock, it failed spectacularly after trying to hold on for a week after the dam was finished. This mistake actually killed around 400 people near the dam. So as you can see, monitoring this type of ground material that things are built on are a very important part of civil engineering that needs to be checked off for the safety of citizens. And so this particular part of civil engineering is called geotechnical engineering. Okay, so geotechnical engineering touches upon many different things. One of the most important things that it touches on is assessing the engineering properties of subsurface conditions such as rock, soil, and groundwater. This is very important as we need the foundation of all of our structures to be strong. If we do not have a strong foundation, any other analysis of the building is a complete waste. As you can see in the dam, they did not look at the type of rock the dam was built upon, so it failed. Another thing that's very important is planning infrastructure projects and telling us where it is safe to build and what is safe to build on top of those rocks, as well as preventing seismic failure, landslides, sinkholes, as in just like the example that I just talked about with St. Francis Dam. Next slide, please, Kayla. Okay, so about the future of geotechnical engineering, as we are in the 21st century, many new technologies have been optimized and made more efficient and easy for civil engineers to use. We can now utilize many different tools to gather information about underground without spending the time or effort to dig. Right now, we're able to detect soil and rock compositions as well as groundwater easily with just a scan. And we are also able to run simulations through the computer that can easily predict these stress failures. As you can see on the slide, this is just one of the geotechnical softwares that can help predict the stress that the rock or ground is going through. So you don't have to have another tragedy like the dam incident. Yeah, I'd like to pass it on to Parson for our next subsection of civil engineering.
Awesome. Thanks, Justin. So for structural engineering, it's really fitting that I picked this image in terms of describing structural engineering because the only response for the poll was bridges. And it's very common for the mental image of civil engineering to be associated specifically with structural engineering in terms of bridges. So at its core, structural engineering consists of numerical analysis of physical forces, so everything you learned basically in physics or will learn in physics, acting on a specific structure. So whether that be bridges, whether that be skyscrapers or tunnels, all of those structures. These forces account for example, the weight of the building or the tension in those cables for the Golden Gate Bridge, additional weight on top of that structure, whether that be from people walking on it or cars driving along it. So taking all of those numerical analyses into account and then designing specific elements for that specific structure to sustain the forces to account for all those forces. So the thicknesses in this case of that cable that runs along the length of the Golden Gate Bridge was engineered specifically in terms of the material used and the diameter of that wire used basically, because every single one of those wires can only account for a very small fraction of the weight that the Golden Gate Bridge can sustain. And structural engineering is really just this constant balancing act between stabilizing structures relative to their environment. And if structural engineers are not careful enough to take into account the different variables that arise in designing a building, things can fail. Next slide, Kayla. So we wanted to play this famous video of a failure of a bridge to show what might happen should calculations become wrong or different variables are not taken into account correctly.
Dawn of a fatal day, and the wind begins to speak with a roar that no man can fail to hear. In a 40-mile-an-hour gale, the center span weaves like a ribbon in a swinging twist that you wouldn't believe possible unless you could see it as you do now. There's an automobile caught on the heaving roadway. The 11,000-ton center span twists and strains the giant cables that support it. Cables of 6,300 wire strands, each 17 inches thick. Back out of the danger zone, all stricken spectators are driven to safety as the bridge gyrates like a nightmare high above the river, twisting, turning, curling. The lone motorist is forced to abandon the car. He has but a few minutes in which to save himself. Face to face with fate, his destiny hanging in the balance. Will he heed the last warning or perish with the doomed structure? But he saves himself by seconds. No structure of steel and concrete can stand such a strain. Steel girders buckle and giant cables snap like puny thread. There it goes! Engineers are divided as to the cause of the disaster. Some claim it was the use of solid girders. Others differ. But whatever the reason, Tacoma will rebuild. This time a bridge that will not provide a super thrill in the news.
Awesome. So the video you just saw was the Tacoma Narrows Bridge, which spans the Puget Sound in Washington. It was the third longest bridge at the time. Third longest suspension bridge at the time, which was 1940. And this video is quite popular in terms of structural engineering because it shows the drastic failure that a bridge can face. And the very basics of the physics is that on the right hand of the screen, the top portion shows you the path of the wind. And essentially, because of the geometry of the bridge, it caused the bridge to sway. And when it wants to return to its equilibrium, where it wants to stay, the momentum it's built up wants it to sway the other way. So same concept when you're on a swing and someone pushes you, the more and more they push you, the more you just swing. And in this case, the more the bridge twisted and it caused it to fail drastically. Next slide, Kayla. So structural engineering is basically creates the skeleton of any building. So the outside that you see is just a facade. That's when structural engineers work alongside the architect to support the image that the architect has. But essentially, the building itself, structural engineering focuses on the core, the skeleton of the building to make sure that it stands properly and correctly. And some of these photos really just show very famous structural engineering feats. The top left is interesting because that's one of the softwares used to analyze buildings. And I believe this one's showing load paths, just to show where weaknesses of the building is located and where structural engineers need to create, again, different elements to support those specific portions of the building. So in terms of future outlooks, structural engineering has a really, really bright future because as decades go on, populations within cities will definitely increase, and structural engineers now face the greater challenge of either building taller or building more resilient, or both, due to natural hazards such as wildfires or earthquakes, and being able to account for the growing population. So it's a really bright subset of civil engineering. The next one is systems engineering. And even as a senior in civil engineering, systems is not the easiest concept to grasp because we can't narrow it down to one specific item. Like a geotechnical engineer can narrow it down to something like a dam, or a structural engineer to a bridge. But systems are special because they focus on large, complex systems, which is really useful now in the 21st century because of technology, Internet of Things, allowing sensors to communicate to each other. You can throw in AI in there for machine learning capabilities for buildings and different technologies within buildings. So the focus of systems engineering is understanding complex large-scale systems and developing tools for their design and operation. Such systems encompass built elements, in the broad sense. So that's infrastructure, transportation structures, etc. Societal systems such as social networks and population enterprises, and natural systems such as land, air, water. And these systems really are at the core of civil engineering because moving forward with increasing use of technology, all of these systems will become interconnected, and there's a lot of things you can do. There's a lot of things you can optimize in between systems. And one of those bright future is actually transportation, which Justin can talk to you more about.
Yeah, who's been in one of these before? Everyone doesn't like them. I'd assume you guys all don't like them because these traffic jams just take up all of our time, preventing us from getting to where we need to go fast. Well, this actually falls under the scope of transportation engineering, where the transportation engineers have to try and optimize the road for maximum efficiency at all times of the day. Of course, we can't optimize it to 100%, but we are getting closer to it every year. Because we can't optimize it to 100%, we always end up with some situations like this. Yes. Next slide, Kayla. So transportation engineering consists of planning infrastructure projects that encourage safe and efficient transport, actually designing the infrastructure, operating the finished product, and finally maintaining the infrastructure for years to come. As stated before, transportation consists of a lot of different projects which hold roads, highways, railways, waterways, airports, subways, trains, and anything else you can think of in its repertoire. All of this requires some sort of transportation engineering. Next slide. Yeah, so with new transportation technologies coming in, it's become much easier to analyze things that would take real life examples to test. So with the addition of computer model optimized infrastructure and traffic simulation software, we are able to decrease the amount of traffic jams and make safer roads for everyone, which is a big win. One of the softwares for traffic simulation is called the SimWalk Road Traffic Simulator. If Kayla can play the video. Yeah, so as you can see in this video, everything is simulated down to the pedestrians and different type of cars. This is really good for our new transportation technologies, as I said before, it can act to decrease the amount of traffic jams and make safer roads for everyone, which is always a huge plus. Yeah, in addition to all of this transportation technology, we'll also have new modes of transportation, such as the Hyperloop, self-driving cars, and on-demand ride services like Lyft or Uber. Yep.
Okay, cool. Yeah, so we just discussed 6 different civil engineering disciplines that, as you can see, cover a variety of topics and subjects, but are very necessary to the world we live in. So now we're gonna go discuss a little bit more about life as a civil engineering student. This can apply to whichever college you decide to attend or wherever you go. So in your first and second years, you'll typically be taking these classes here. So some calculus, linear algebra, chemistry, physics, and programming. So these are your technical foundational classes. And these are classes that, as I mentioned, every engineer and scientist will need to take to get into, to go further into their field. And these classes are foundational because you, as a civil engineering student, will need to apply what you've learned from those classes to your upper division courses. And upper division courses, I personally speaking would say they're definitely more fun just because they're more applicable to what you want to study and do. Currently I'm taking a variety of courses that cover 3 of the 6 disciplines we've discussed. So you'll have your fundamental civil engineering courses, civil engineering applications courses, and civil engineering design. And this also applies to other types of engineering and other majors. So my advice for when you take classes, definitely do your best in your lower division courses, because those are the ones that are the foundation for your upper division courses. Parson and Justin, if you want to add anything about classes, feel free.
Right. I just wanted to highlight what Kayla said, that the lower division courses that you take, regardless of what university you end up attending, are really crucial because they lay the groundwork for your later understanding of different courses. And it's fairly common for college students to agree that typically the first courses that you take at any institution may not be the most interesting to you because they have to deal with the incredible fundamentals of math, physics, chemistry, the really nitty-gritty science-related courses. And then using the knowledge that you accumulate in those initial courses, that's when you apply them for your upper division courses. And I definitely agree that upper division courses are way more fun than lower division courses because you can really see how what you're learning in class can translate to the industry or to academia if you're interested in research and pursuing an even higher degree of education.
So yeah, getting involved. So we 3 are a part of the American Society of Civil Engineers at Berkeley. And that's one of the organizations that we have taken part in early on in our careers. So as first years, we each individually joined the club early on just so we can meet new people, meet new friends, start networking and talking with upper division students. And with that, I would definitely suggest finding a mentor in those organizations that you join, whatever it may be. And then of course, in terms of classes, as we mentioned, you'll have many professors, and going to office hours is definitely a good resource because you can ask questions about the classes you take, but also ask your professor about professional life and how you can get a job or what parts of the industry you might go into. So it's definitely something that takes time in the beginning. Of course, as a first year, back then, I was definitely shyer than I am now. And I think I could speak for all of us when we say that we were shy in the beginning, but once you get out of your shell, you're able to seek out different resources, seek out mentors, and definitely find your niche wherever you go. So that would be some of the tips I have for getting involved.
Yeah, I really want to emphasize, please do join clubs and organizations early on. I was actually a freshman last year. I'm in my sophomore year right now. Joining ASCE and some other clubs at Berkeley have really helped me get connected in the CE community. If I have not done that, I think I would still be just studying in my dorm room, just all alone. So definitely, please join the clubs and organizations early. Yeah.
Yeah, I think a college experience is really, it depends if you ask people different ratios, but I would put social clubs and just organizations in general to be like a 60% cut of your college experience, and 40% is all the technical stuff that you would need to learn to go to academia or industry. It's really important to get to know a lot of people very early on as a freshman. If you want to talk to different professors, you have the best reason to, and it's because you're a freshman. You're just curious. You just want to know more about them, more about the class, more about their research. And really just going through these cycles helps the professors or your teachers just familiarize you to them. And it becomes very easy later on in terms of asking for letter of recommendations, or in terms of developing a real relationship with your professors in terms of a mentee-mentor type of thing. But in those situations, I want to remind you that that is a two-way street. They do learn a lot from you as a mentee, but they also would ask you to bring the same energy and bring your interest to them as a two-way street as their mentor. But yeah, definitely. I started with ASCE as an intern my freshman year. I was just really curious about the organization. And then little did I know, I met so many people in different clubs, studying different specializations within civil engineering. So I have friends across all of these 6 different programs, specifically at Berkeley, but generally speaking in different programs under civil engineering. And the support I received as a freshman really just propelled me to complete my academics, learn how to speak properly to different people, really brought me out of my shell because I was really shy as a freshman too. But I think it's really important now for me to really appreciate the fact that I was an intern back there. I was really shy, but now I am president of the same organization that was really interesting to me as a freshman. And we're really lucky to have this opportunity to give back to more students who may have been in our shoes, because as a high school student, I had no idea what civil engineering was. The only reason why I chose the major was, one, I know I like talking, but I also like STEM. And in my search for different majors in different colleges, it seems that civil engineering was a good fit. And every single year, I'm kind of glad I picked civil engineering because I learned to really enjoy it and really enjoy it with people that I like and develop relationships with at our college.
Yeah, very well said, Parson. Yeah, that actually concludes the presentation portion of this workshop. So yeah, we thank you for listening to that, listening to all the disciplines, and we hope you learned something about civil engineering. And whether you choose to go into this major or something similar or something completely different, we hope you choose something you enjoy and are passionate about. And when you get to college, it's okay to also not know. But yeah, we really enjoyed speaking with you, and we can take any questions if anyone has anything. And then for the future, Ms. Vaccaro, I'll send you a link to contact information for other people if students want to contact students for certain disciplines.
Yeah, that would be fantastic. And if you could also put it in the chat for those who are here, because sometimes it's easier just to copy and paste.
Okay, yeah.
And if they are just interested also, maybe they're not sure they're doing engineering, but they're really interested, like, well, what's life like at a place like UC Berkeley, especially for us Bay Area folks close to home? Is that something that you guys are okay at answering those questions too?
Yes, definitely. We've included our personal emails here. So whether it's civil engineering related or not, or just anything about Berkeley or college experience, feel free to reach out to any of us. We'll be happy to answer any of your questions.
So this is your moment, everybody. Whether you want to do chat, you want to unmute yourself, and in case I did not give you power to unmute yourself, raise your hand so I can do that, and ask questions. And we have one already. So how do you know this major was for you? How did you find the balance between STEM fields, classes, and social life?
Parson, you can take it if you want.
I'm too old to answer that, so you guys have to do that.
Okay, like I said, I wasn't really sure what major I was stepping into, applying to different colleges. But I had, I guess, a gut feeling in terms of that, because I just knew that, again, I like to talk and I loved STEM in high school. It seems like a really good meeting point for civil engineering. But now that I am in Berkeley, I've just really enjoyed civil engineering. We communicate with the public more often than any other field in engineering, I would say, maybe specifically to departments in Berkeley. But civil engineers, you need to be able to speak technically to your engineering colleagues, but also turn around and speak to a residential homeowner, for example, whose pipe just broke in their home and the reasoning as to why their pipe broke at home. So you have to be able to switch that ability to talk technically and to talk socially with a different person. And in terms of the second question, the balancing act between STEM classes and social life is really, it's an ongoing process. Sometimes you have weeks where like I'm buried with all of my work from classes because just so happens that a lot of the assignments are just due at the same week. So of course that's really difficult, but I have weeks where I get to relax because I finished all my work pretty early and I don't have any really assignments during that day. But it's really an ongoing practice, and you definitely get better with it as you go on to your academic career in college. So the best advice really is just to listen to yourself, which is really cliche advice, but it really is true. You know your the extent that you can perform academically, and you know the hours that you need to put in classes to make sure that you're doing fine and you're comfortable with the material. I would also encourage you to go the extra step in terms of not putting enough hours just to understand the material, but put enough hours so that you're able to really have a high level understanding of the concept, and maybe you're able to see how different classes that you're taking overlap with each other. And that's where really, I guess, education comes in, because you understand a really broad subset of engineering in general.
So what classes proved to be extremely helpful towards civil engineering that you did not initially see the correlation? And if you don't mind, since you know, if you could mention like some high school courses. I know for some of you it's a little bit longer than before, but what was something that was like, I've seen this before?
Ms. Caro, Kayla mentioned something in the chat about disabling her.
I just took care
Awesome.
of it.
Got it. Okay,
Sorry.
Yeah, so for high school courses, just speaking from experience with being an SI alum and the kind of courses that we have here, there's definitely a lot of great classes that SI offers that will prepare you for this type of field, especially with the lower division classes that we mentioned, math, science, we have physics, we have chemistry at SI, and it's definitely something that fortunately I was able to have and use for my lower division classes. So luckily I was able to succeed and do well in certain classes because of the education that SI provides. SI is a special school. We're very fortunate to be able to attend this school, and with Magis, that's definitely an extra community and resource for you within SI. So technically speaking, with like the classes, SI definitely prepares you for college life, wherever you decide to go.
And Kayla, do you mind addressing, did you take engineering at SI? Sometimes students feel that they have to take engineering. And my emphasis, no, it's the calculus, the physics and the chemistry is really key. The engineering is just more of a nice personal supplemental.
Yeah, so I actually didn't take engineering when I was at SI. I focused more so on like the AP math and the AP physics. So that's kind of where I went. If you have the chance to, definitely take engineering if you have the space, because it'll definitely give you an intro into what you'll be doing. But I would say definitely focus on the more technical classes, because those are probably the priority that you'll be facing and dealing with the first few years of college. But engineering is definitely fun. Mr. Santos, I'm not sure if he still teaches it. He still does, yeah. He's definitely a fun teacher, so it'll be exciting whether or not you are able to take engineering with him.
Yeah, and you also guys know that you have the robotics class too. And then also for all three of you guys, can you talk about the experience going to a large university? Though SI is large, I think when you're in a campus of 30,000 in that freshman size classroom, I still remember when I even went to my sister's engineering. She's like my big sister. So, and she had to babysit me. So yes, guys, I was taking college classes when I was in elementary school, but she was doing all the hard work. Can you talk about that? Because I always share stories that I had a student who literally was refusing to apply to UC. and then they did just because of a lot of affordability options, and now thought it was grateful. But there's this fear factor of the what rumors are like untrue and what rumors are true, and how did you cope with that?
Yeah, so I could speak a little bit about it and then we could rotate. So UC Berkeley is definitely a big university. And luckily, if you decide to go into your specific college, so College of Engineering, for example, that's like a community within a larger community. And then with that, you have your own major. So you have your major community within the engineering community within the larger Berkeley, UC Berkeley community. And then, yeah, you'll really be able to find, like challenge yourself to join different clubs. Because then when you find those clubs and when you get comfortable with the people in your clubs, Berkeley won't seem as big as it sounds right now. Just speaking from personal experience, I was fortunate enough to do this program called the pre-engineering program before I actually got into UC Berkeley. So 3 weeks before we started our first day of school back in 2017, I already had met people that I see in my classes now. Parson and I both did this program, and we were able to have a community before we even started. So there's definitely a lot of resources and programs that you could attend before you actually get on campus, just to help ease that transition, moving from high school to a big university. Oh yeah.
Oh yeah, I can go now. Trying to find your place at UC Berkeley is not as bad as you think it might be. You just have to put yourself out there. You have to be proactive in trying to find your niche. I was a freshman last year, so this is like very present in my memory right now. So I was actually very shy back then. Didn't like talking to people, but I knew that once I went to a school with like 30,000 people, I needed to put myself out there to meet other people. So what I would do is I would just go up to random people in lectures, talk to them, because there's a good chance if you're in an engineering lecture, you'll be able to see the same people in future classes that you might take with them. So you can make those connections on your first day of school or just sitting next to them or whatever. Also, please join clubs and organizations early on. That's a great way to find a community and where you can find some really good friends. A lot of my friends from UC Berkeley right now are from ASCE and one of my competition teams that I've joined. So yeah, just put yourself out there. Don't be shy. Just try your best. That's my advice.
And Parson, before you begin, and other guys could touch on, because we're near the end of our hour for our presentation. And again, guys, if you have some burning questions, ask. I'm just going to ask two, but so if you have some, please make sure before our wonderful guests leave. But can a lot now with COVID-19, I'm going to ask you guys put your engineering problem-solving hats on. A lot of engineering colleges, whether it's UC system or out of state, are looking for, hey, how have you demonstrated your love for engineering? And I think a lot of people assume, okay, I have to get this internships. And that sometimes it's hard because it's so competitive. They didn't find out, they have family responsibilities. So if you were a high school student again, what would be some things that you would do as in a pandemic mode that doesn't require a lot of resources for you to demonstrate to your future campuses that you love engineering and you're that future problem solver, AKA superhero?
Parson, or I could take
Parson or anyone, yeah.
Okay. Yeah, so if I were in high school and had to demonstrate my love for engineering, I'd probably take on some side smaller projects. I know there's a bunch of websites such as Coursera that high school students have access to for free, where they could take on a small project, find something you're passionate about, and then So if I were in high school, I'd probably do a small engineering project on my own, even if it's something as simple as creating like a engineering blog, or building something in your backyard. That's something that you could definitely speak to in your college essays, for example. And yeah, because the just like on a side note, because the SAT and ACT aren't something that will be necessary for the upcoming cycles of applications, definitely build a portfolio of things you've done relating to engineering or whichever major you decide, and include that in your apps and your essays, because it'll definitely show that you've taken some sort of initiative to take on smaller projects. Yeah, so that's something that would definitely be beneficial.
Yeah, so whether you're in engineering, exactly what Kayla is saying is so key, because of this test optional, or some campuses like Berkeley are not even using tests, even if you submit it, even for the class, starting with class of 21. That's what they're going to be looking at. So thank you for mentioning that. And then my last question, unless again someone else in the group, and this goes for everyone, whether you're an engineer, I still remember going to my sister's engineering graduation at UC Berkeley. We saw all the engineers at the Greek Theater, and I hope that you guys will be there too. And I remember counting only 4 females, including my sister, and only one person who identifies BIPOC in that whole circle. Now, this was a while ago, but unfortunately, like I've said, since I started counseling in last century, this is something that we still need to mean, because diversity of ideas and background just makes us all more wonderful and stronger together. So anything that you could address, even whether it's about, are there faculty members from different backgrounds? If you feel comfortable sharing, how do you deal, like if you do feel isolated? I mean, you know, especially in anything in STEM, or even on a college campus too. You know, that's why, if you guys don't know, November, they're on the ballot. They're going to vote on reversing Proposition 209 that eliminated affirmative action for all the public schools in California. So could you guys address that? Because I think that's something that's really important to put out there, because even today, just to let you guys know, my sister's, she's a VP of her engineering firm. It's one of the biggest ones in California. She's the only female. And then when I look through the list of all the top people there, everyone pretty much looks the same. And it's sad, and she addresses that it's an issue as she goes. Her first job, someone asked her to get her some coffee. So just FYI, but no one does that anymore. So anyway, enough about me. Can you guys address that as a student, especially, and then how you're preparing yourself emotionally and socially, especially as you guys go into the workforce too?
Yeah, the concept of like diversity, equity, inclusion is quite popular very recently for the Department of Civil Engineering at Berkeley. There are still a lot of things that could be improved on in terms of representation, faculty-wise or student-wise, at UC, at the Civil Engineering Department, or generally speaking, just more in the industry. The companies that I've interned in the past could use a little bit more of diversity, and diversity is never a bad thing. It brings out diversity of ideas from diverse backgrounds and diverse, you know, methodologies and thinking about things differently. I don't know how I feel about it as a student, because I've tried to look for support systems very early on in my college career, who I guess unconsciously just reflect a version of myself. My friend group is fairly diverse in terms of backgrounds and you know, just backgrounds in general. And I think I've built a good network of closer friends that I can rely on should I face any discrimination in classes or in industry while working. It's difficult, definitely, but a lot of things can be improved. And the biggest takeaway I've taken as a student navigating these spaces is that you need to be able to advocate for yourself. that really is it. You need to be able to advocate for yourself and know your worth. And just because you're a student and a professor says something to you does not, it should never really happen just because of that power dynamic between a student and a professor. Because ultimately you are there to learn. You're not there to, be subject to a lot of different things that some students are subjected to. So really just, you need to learn how to stand up for yourself, advocate for yourself. You need to know the resources on campus that you can go to should anything happen to you that you need support on. It's just really important to be aware and be cognizant of the fact that just because, there's that power dynamic between a student and your boss for industry or your professor in class, there are still some things that you need to fight for yourself. And sometimes it's an independent battle that you have to deal with. But of course, it's really important to find a really good support system to back you up. That was a really roundabout answer, but it's a weird way of navigating the space.
No, I appreciate that, Parson. There is no, I think we're all trying to figure that out, like you guys said that, and it's an issue that I'm glad it's in the forefront of people's mind, but it's been an issue that everyone needs to take charge of, so that we, even while we're apart, to work on this together and solve together, so we all be problem solvers in multiple levels. Again, thank you guys so much. Parson, Kayla, Justin, let's show some emoji reaction love. Feel free to shout out. Thank you for being so informative. I think you actually informed me more than my own sister did. I love her. She's just so busy. But wait, but I think we have one last question. I just saw it. See, it's always when you say it's almost goodbyes. But I have a question, then I'm going to go into the one in the chat. Real quickly, we do have a podcast. So if you guys are open, Kayla has my email. If you want to call in to do a podcast show, we would love to spread this good news and information to our community and the world. So FYI, if you want to do that, I would love to have that as my guest. But we have a question, a few plans for how I'll go with college. Just want to know if any of you know of a path of transferring into engineering after completing that core courses, whether it be also, like the GE. And if you don't have that answer, I'm happy to help you guys with that. But do you have any classmates, especially Kayla and Parson, that did transfer into UC Berkeley as an engineer?
Yeah, so in terms of our college and the CE department, typically what happens if you want to transfer into Berkeley is that you'll go in as a third year after completing your general ed courses and your general technical classes. So there's definitely, every year, there's definitely a new cohort of students that joins Berkeley from community college, for example, or from a different major that goes into the civil engineering major. So there's definitely a way to do that. I'm not really sure about the acceptance rate, so to say, for example, but we definitely have friends that have transferred into civil engineering or from a different major.
Yeah, and then Parson wants to know maybe answer this for both questions. So for community college, just to let you guys know, there are agreements between universities, and some of them have a guarantee. Berkeley isn't because of how competitive it is, but most of the UCs, minus the most competitive ones, even into engineering. But is there a follow-up? Also, a Parson asked, what if I wanted to transfer from another four-year college into another four-year college? Do you know of anybody? And then I could talk a little bit about the specifics about how to go about that.
Right.
Oh, go ahead.
We know a few folks that transferred from community colleges to UC Berkeley, and they did so. Their transition was pretty good. But to my knowledge, before you plan on really transferring, you need to be aware of the requirements at the institution you're transferring into, so that your current institution, you've taken the courses relevant for that university. And for the case of UC Berkeley, I know students who came from community colleges who took way more classes compared to what Berkeley really has, because there's a difference in level. So for example, one math class at Berkeley can be equivalent to a series of classes at a different institution so that both requirements can be met. So there's a lot of planning for the student. So I would really suggest talking to counselors, college counselors about it so that you can plan accordingly to make that transfer the best experience possible.
Yeah, and if you're really interested, community colleges is the easiest route because it's written in their language. That's what their agreement. It's called assist.org, where you could take some classes. Some of you already done that. So for our younger folks out there, class of 22, 23, 24, you could take for free community college classes to get even ahead and make your profile look awesome as well. When it's just kind of like what Parson says, if you do decide not to do a community college but private school, make sure before you're even considering that with the transfer office of that UC what to do, and even to transfer into, even though it's both civil engineering, for example, let's say at UC Irvine versus UC Berkeley, they will have different requirements. So they're maybe from the same family, but as you know, each family member is different. And so you have to be very, it's a lot of, community college it's easy to get in, but it's complicated to get out if you're especially unorganized. So that's something that's really important to be aware of. And of course, we are here to help you. So once again, unless we have another question, whether it's about engineering or just in general Berkeley, thank you guys, Parson and Kayla and Justin. Hopefully you will say yes to my podcast interview thing. But if not, thank you so much for all this information. It is recorded, guys, so it will be shared to all you guys. But once again, let's give a lot of Maj's love, emoji, reactions, air, applause, all that good stuff. Thank you, thank you, thank you, guys.
Yes, thank you so much for having us. This was really nice to talk and give to you all. And good luck with the Maj's boot camp. You'll definitely do great. Yeah, can't stop, won't stop.
That's right.
Definitely it.
Thank you, Kayla.
Okay.
Thank you, Parson. And Parson, thank you for putting your link on LinkedIn. You put some rave reviews on them about their great presentation skills. That helps for employment, FYI. Give some love. Love can come back your way. Justin, thank you so much as well, too.
Yeah, thank you too for allowing us to come here and speak to you guys.
Yeah, thank you so much. And again, the slide deck that Kayla will share at a later time, all the students in that list are open to answering any questions you might have. They're really just open. We were in your shoes at one point or another. Definitely reach out, use us as your resource, or just get our feedback about college in general, civil engineering in general. That'd be totally fine. Thank you so much for your time.
Thank you,
Yes,
guys.
thank you. We'll follow up soon. Thank you. Bye-bye.
So guys, thank you so much for all you guys. I am stopping the recording.